Welcome to the Westernacher 9-part webinar series about SAP's Extended Warehouse Management, beginning with Part 1, Introduction to EWM for the Logistics Managers. In this webinar we will cover the following topics: how EWM evolved, introduction and core processes of EWM, a live system demo, and possible next steps towards moving your company to EWM. My name is Neil Whiteman, and I am a Senior Consultant Partner at Westernacher Consulting. I will now lead you through this webinar. We'll start off with a short introduction. Westernacher is a global consulting firm and special expertise and silver partner of SAP AG in the area of supply chain management as well as other areas. We have a business area that specialises in the implementation of SAP solutions in the field of supply chain management and warehouse logistics. This webinar is aimed at supply chain managers and warehouse logistics managers and heads, and it is the aim of this webinar to give you an insight into the use and the key functionalities of the SAP EWM solution. There are further SAP EWM webinars, parts 2 to 9, available which look at the key functionality and use for your business. The other webinars in the series are listed in this slide and can be accessed through our website at www.westernacher.com after completing a short registration form. But let's get started in talking about EWM itself and where it comes from. The question often arises, why not just modify my existing warehouse solution rather than implementing EWM? Well, in some cases this may be appropriate, but in general EWM represents a significant shift away from the architecture of previous SAP warehouse products. This redesign was necessary to respond to the changing world of logistics. Reasons for the new design include significant increases in data volumes, performance, and the need to be flexible and adaptive to new business processes. System availability required 365 days a year. WM is rigid in its design, whereas EWM offers much more flexibility. EWM is a completely new solution built from the ground up based on SAP's extensive experience in warehouse management solutions, and is geared towards helping customers maintain ever-increasing service level agreements with its flexible approach. Compared to the previous SAP products, EWM is designed to manage anything from raw materials to finished goods. It is also capable of handling far more sophisticated requirements. EWM is also constantly being improved by SAP, meaning that new functionality will only be released into this version of the Warehouse Suite from SAP. SAP's history in warehousing goes back to the early 1990s and has been continuously developed ever since. EWM itself was first released in 2005 with version 5.0. This table helps to compare the functionalities across the SAP suite. EWM is a step change, offering many functions out of the box. It is common to find that customers have developed bespoke enhancements to close these previous gaps. These gaps are now generally closed by EWM. An interesting point to note is that SAP's Extended Warehouse Management is the next generation warehouse management system from SAP. It is not a replacement of ERP-WM. EWM is designed to manage complex logistics execution in the supply chain. EWM efficiently handles all internal processes of a warehouse efficiently. Goods receipt and goods issue, complex cross-docking, slotting, packing and shipping logistics, as well as cross-functional activities such as logistics service provider integration, labour management and analytics. Now that we have covered the pedigree of EWM, let's look at it in more detail. Most companies work today is service performance oriented, with a clear alignment on the customer. In order to run its entire supply chain smoothly, high demands are placed on warehousing. In order to fulfill these increasing requests, companies require warehouse management systems with higher efficiency, flexibility and transparency. SAP's EWM helps to improve the service level through state-of-the-art warehouse processes and delivery processes dramatically. In contrast to LEWM and TRM, EWM offers a completely new warehouse core that makes multi-step transportation with integrated stock unit administration possible. The physical location of a material is always well known and supply can be online administered. EWM's core functionality is represented in this slide. For the remainder of these slides, we will talk about the key functionalities offered in the highlighted areas. These are slotting, wave management, warehouse order creation, value-added services and kitting, cross-docking. After a short overview of each of these, we will launch into the system demo. The first core process we will look at is slotting. Slotting is the process used by EWM for determining the optimum storage position for each product to ensure the most efficient storage and picking available in the warehouse. During slotting, the system determines the following storage parameters and stores them in the product master: put-away control indicator and optionally the stock removal control indicator, the maximum allowed quantity in the storage type, storage section indicators and storage bin types. The optimum parameters can be stored as planning values on the product master and activated at any point in time. The requirement or demand data can come from APO or any other planning system. The benefits of slotting include reduced effort through automatic physical criteria to find the appropriate bin type, space optimization, demand criteria to find the appropriate bin section, time optimization, and rule-based rearrangement of material in the bins, closing the optimizing loop. The next core process is wave management. Using the wave management function, EWM combines items or splits items from warehouse requests for outbound deliveries into waves. These waves must be picked and processed at roughly the same time. Waves can be created manually or automatically in EWM. A wave is a grouping of warehouse request items used to control the warehouse activities such as picking or posting changes. These groupings are then processed together in subsequent processes. For example, the transfer of all warehouse request items assigned to a wave at a certain point in time to warehouse task creation. The warehouse task items created are then forwarded to warehouse order creation. The benefits of wave management include increased staff utilization through fully automatic work control, an overall reduction in transaction times, more control and greater visibility over the outbound picking operation, which allows more flexibility in delivering to customer demands, and central planning and control of independent waves for different warehouse areas. The third core process is warehouse order creation. EWM uses warehouse orders to bundle one or more warehouse tasks into work packages. Every warehouse task is assigned to a warehouse order. Warehouse orders are most beneficial in system-driven processing. The main purpose of the warehouse order creation is the picking process and flow optimization. Every time a warehouse task is created, the warehouse order creation will be triggered and warehouse orders will be created for the warehouse tasks. Warehouse orders are assigned to the users in resource management. Warehouse order creation rules consist of one or more of the following selection parameters: activity areas, sort rules, item and sub-item filters, limit values, and packing profiles. The benefits of warehouse order creation include optimal work packages for outbound processing, pick path optimization, the ability to measure times for each part of the warehouse order process, and reduction of the subsequent packaging expense through optimized pick path strategies. The next core process is value-added services, or VAS. VAS orders are used to perform value-added services within the warehouse. Typical VAS activities include the assembling of products, the packing of products, labelling or kitting. VAS orders can, for example, be used in the goods issue process to assemble kits for your customers and to pack them on a customer-specific basis. VAS orders can be created manually or automatically. Orders for value-added services are based on packaging specifications, and they can be used to track the time on each VAS activity within the order. They are used as a basis for billing customers for additional activities, and are fully integrated into the inbound and outbound process as part of the process-orientated storage control. Benefits of value-added services include the integration of almost any activities with customer-specific packaging and auxiliary materials, a flexible and fast reaction to dynamic customer requests, and full traceability and transparency of all value-added services. The final core process is cross-docking. Cross-docking is the method that EWM uses to optimize the processing of inbound and outbound deliveries without storing the products in the warehouse. Cross-docking reduces the handling of materials in the warehouse, potentially avoiding damage and additional labour requirements. There are two types of cross-docking available. Planned cross-docking. The cross-dock decision is made before the goods arrive at the warehouse. Opportunistic cross-docking. The cross-dock decision is made when the goods arrive based on demand. There are 5 methods of cross-docking supported by EWM. Transportation cross-docking, merchandise distribution, opportunistic cross-docking, push deployment, and pick from goods receipt. The benefits of cross-docking include the speeding up of the flow of the material through the warehouse, the reduction in storage space requirements and stock keeping costs, and it can help to reduce transportation costs by consolidating cross-dock materials and materials from storage. In this next part, we will demonstrate SAP EWM Live, the so-called look and feel demo. Before we start off, here's a quick run-through of what you will see. For the inbound process, we will start off in ERP, where we will create a purchase order and inbound delivery. Then we will go into EWM to process the unloading, count, put away and posting the goods receipt, and finally check the document flow. For the outbound process, we will start off again in ERP, where we will create a sales order and outbound delivery. Then we will go into EWM to process the picking, packing, loading and posting of the goods issue before checking the document flow. So let's begin with the inbound demo. We start off in ERP, where we must first create a purchase order. To do this, we follow the menu Logistics, Materials Management, Purchasing, Purchase Order, Create, Vendor, Supply and Plant Known. For the demonstration, we will take a copy of an existing purchase order in the system. We do this by dragging it into the shopping basket. Here we can see the vendor details, our material, purchase order quantity, receiving plant and receiving storage location. We save the purchase order and our number is displayed at the bottom of the screen. The next step is to create the ERP inbound delivery or shipping notification. We do this by using the menu Logistics, Logistics Execution, Inbound Process, Goods Receipt for Inbound Delivery, Create, Single Document. Our purchase order number is copied through from the previous transaction. Here we can see again the vendor details, our material, plant and storage location and delivery quantity. If we check the delivery header, we can see that there is a flag for Decentralized Warehouse Management. It is set at status A. This means that this delivery, once created, must be distributed to our EWM system. We save the inbound delivery and our delivery number, and a message informing us that the delivery was distributed to the WMS is displayed at the bottom of the screen. The distribution to our WMS system can be an automatic process, manual process, or via a background job. Let's check now in EWM to see if our inbound delivery has been received. In EWM, our ERP inbound delivery is received as an inbound delivery notification. We can access this via the menu path, Extended Warehouse Management, delivery processing, inbound delivery notification. We enter the ERP inbound delivery number. This document within the EWM system serves as a notice to the warehouse that a delivery is due to be received. From the inbound delivery notification, we create an inbound delivery. This creation can happen automatically in the background. Here we can check the status of our notification on the status delivery creation, which has a value of 9 completed. This means that our inbound delivery within the EWM system has already been created. We can check this by clicking on the inbound delivery button. Here we can see the EWM inbound delivery. It is given its own unique number in the EWM system. In our example, the number is 7714. We can see the warehouse door where the goods will be unloaded. The next step is to create the warehouse tasks to put the goods away in the warehouse. We do this by selecting Inbound Delivery, Follow-on Functions, Unload. Here we can see our handling unit which we need to unload. We select the Unload Warehouse Task button and save the warehouse tasks. The message 2 warehouse tasks were created is displayed at the bottom of the screen. So now let's check at the Warehouse Activity Monitor to see the status of our inbound delivery. The Warehouse Management Monitor within the EWM system is a central cockpit and reporting overview of all warehouse activities. To access this monitor, we use the menu Extended Warehouse Management, Monitoring, Warehouse Management Monitor. For our demonstration, we will select the Inbound node and enter our EWM inbound delivery number. In the top section, our inbound delivery header detail is displayed. The bottom section shows all of the item detail and all of the activity within the warehouse. Here we can see our warehouse tasks. Our first task created is to confirm the unload of the handling unit from the vehicle into the receiving area in the warehouse. The second task is the put away of the handling unit until its final destination within the warehouse. This task at this point in time has a status of B, which is waiting and cannot yet be utilised for execution until all preceding tasks have been completed. Let's now go to the RF to confirm the unload task. To access the RF application, we use the menu Extended Warehouse Management, Execution, Log on to RF Environment. Here we enter our resource and sign on to the RF application. To confirm the unload warehouse task, we will use the menu O3 Inbound Process, O1 Unloading, O1 Unloading by Delivery. We enter our inbound delivery number from EWM and we enter our handling unit which we wish to unload. We confirm the destination bin of the handling unit. Our handling unit has now been successfully unloaded from the vehicle into the receiving area. Let's check back to the warehouse monitor for an update. If we refresh the warehouse task on the monitor, we can see that our first warehouse task now has a status of C, which is complete. Our final put away task still has a status of B, which is waiting. We now have a third task, as this product, each time it's received into the warehouse, needs to be taken to a work centre for a count. The next step is to move the handling unit to the work centre to perform the count. Let's go back to the RF. To confirm our handling unit at the work centre, we will use the menu O2 Manual Selection, O2 Selection by Handling Unit, and enter our handling unit number. We then confirm the destination bin at the work centre. Our handling unit has now been successfully moved to the work centre. Let's check back at the Warehouse Activity Monitor. Back at the Warehouse Activity Monitor, if we refresh the Warehouse Task List, we can see now that the Move to the Work Centre task has been confirmed. Our task for final put away is still at status B, as we have yet to perform the count of the handling unit. Let's now go back to the RF to perform the count. To perform the count on the RF, we will use the menu 05 Internal Processes, 04 Quality Management, 05 QM Counting, 04 Handling Unit Closing. We enter the work centre. We then enter our handling unit. We close the handling unit as there is no differences to report. Let's go back to the Warehouse Activity Monitor to check the status of our delivery. Back at the Warehouse Monitor, if we refresh our Warehouse Task List, we can see that our final destination warehouse task now has a status of blank, which means it is ready for execution. So let's go back to the RF and confirm the final put away. To confirm the put away of our handling unit, we will use the menu 03 Inbound Process, 03 Put Away, 01 Put Away by Handling Unit, and enter our handling unit number. We then re-enter the destination bin to confirm. Our handling unit has now been successfully put away into the warehouse. Let's check back to the monitor again. Back at the Warehouse Activity Monitor, if we refresh our Warehouse Task List, we can see now that all warehouse tasks have been confirmed. If we refresh the header data, the inbound delivery header data now shows as complete. This means that the EWM inbound delivery has been successfully received into the system. Now let's check back into ERP to see the documents within the system. Back in ERP, we now need to check the inbound delivery. We do this by using the menu Logistics, Logistics Execution, Inbound Process, Goods Receipt for Inbound Delivery, Display, Single Document. Our inbound delivery number is copied through. If we select the Document Flow button, we can see that our handling unit and our goods receipt documents have been passed back up into the ERP system from EWM. Here we can see the inventory management posting of the material. This is the end of the inbound delivery demonstration.